Welcome back. In our last video, we explored how if, elif, and else statements let Python make decisions based on conditions. Today, we're going to get some hands-on to create our very first decision-based program. By the end of this lesson, you'll have a deeper understanding of how to apply conditionals in practical ways and see how software engineers use these same concepts at work every day. Let's jump in. Software engineers often rely on conditional statements to control what their applications do. For example, a login system can check if a username and password match. If true, it grants access. Else, it denies it. Another example is role-based access. If the user is an admin, show advanced settings. Elif the user is a regular user, you're going to hide the admin features. Else, restrict them entirely. Think of your favorite streaming service. If it decides if you're already logged in or if you need to see a login screen, that's a simple conditional at work. If you're shopping online, the site checks your delivery location to see if free shipping applies. Conditionals are everywhere. Today, we'll create a small program that recommends an activity based on the weather. If it's sunny, we'll go outside. If it's rainy, we're going to stay in, maybe read a book. Else, maybe do something indoors but active. The skills we'll be using is going to be if, elif, and else statements to handle multiple possibilities. We're going to prompt the user for input, and we're going to convert that input if needed and store it in our variables. Let's go ahead and open up a code editor and get started. The first part of our program requires us to ask our user for some form of input. This input is going to be what type of weather are they experiencing. This is going to be given to us in a form of a string, and we're going to store this inside of a variable. So let's go ahead and create our variable called weather. And we'll use our input method to receive some form of input. And we're going to ask, how's the weather today? Now, we can also pass in some simple, straightforward examples of input we can receive, like sunny, rainy, cloudy, question mark. That way, the user has an idea of what to give back to us. Once we have the current weather, we're going to start our if-else conditions. We're going to say if weather, and we want to compare this to something very specific. Let's check if it's sunny first. To check if strings are equal to each other, we use the double equal signs. Remember, one equal sign shows assignment, while two shows comparison. We're going to check the value that comes back from the input and saved into weather, and we're going to compare that against the string of sunny. In the event the string of sunny does equal to the value saved into weather, then we're going to print out great. How about going for a walk or playing a sport outdoors? Next, let's say elif, if the weather is equal to rainy, print maybe stay in and read a book or watch a good movie. And for now, let's keep it simple. If it's not sunny, if it's not rainy, it might just end up being cloudy. And I see I have a typo here. Let's go ahead and add a Y to the cloud. Now we see cloudy. If weather doesn't equal sunny and if it doesn't equal rainy, for now, to keep it simple, we can safely assume it's probably going to equal to cloudy. So we don't have to necessarily add an if or elif statement right now for it. We'll just say else, we'll print it might be a good day for indoor activities or a quick trip outside if it's not too bad. And let's go ahead, activities, fix some grammar here. And I think we are ready to give this a try. Let's see if it works. We'll pass in the string of sunny. And I see, great, how about going for a walk or playing the sports outdoors? Let's go ahead and pass in rainy. Now we see the print statement for the rainy code block being displayed. Maybe stay in and read a book or watch a good movie. And now let's say cloudy. And it defaults to our else statement. So it's working so far. Once again, I want to emphasize, notice how we are using the double equal signs for comparison. Now there's something that you need to know. The double equal signs when comparing strings is case sensitive. So if the user types sunny with a capital S, it won't match exactly. We need to convert the user input to lowercase for consistency. They could possibly pass in sunny in all caps, sunny with capital S, or they could be a little funny and just add a bunch of capitalized letters within our words. We need to be able to handle this. So what we can do is after we receive the input from the user, we're going to go ahead and we'll do some formatting of our string. We're going to reassign a new value to weather. And this new value is going to be weather.lower. We're going to use a built-in string method. This .lower method is going to take the string of weather, is going to lowercase it all completely, and it's going to reassign it to the same variable name or container. This is variable reassignment, and we do this because, as you guys recall, strings are immutable. They can't change. So it's just better practice to reassign it just for the fact of that we don't want any kind of weird functionality here. And now, even if a user passes in something like sunny with a capital S, we can capture it. Notice what happens when I remove this and I pass in sunny with a capital S. Earlier, when we were formatting it, it triggered the sunny code block, but here, now it's triggering the else statement. And that's because, once again, to reiterate, the double equal sign is very sensitive to capitalization. It's going to take it very literally. So when it compares the value of weather to the string of sunny in all lowercase, it fails. And it fails that for rainy as well, of course. And it defaults to the else statement. Once again, once I go ahead and I uncomment this out and go back and type in sunny with a capital S, it's now working as expected. Now, let's go ahead and maybe kind of finish this off with some reformatting. Let's take into account our cloudy statement. So now that it's lowered, let's go ahead and now add another elif statement for the additional condition for cloudy. Now, the reason why it's important to still check for cloudy is because what if someone passes in something like chilly or snowing, or it's foggy outside? Maybe, there's some additional weather conditions here that we didn't take into account. We did pass in some kind of guidance to the user to give them an idea of what to pass in, but people are going to naturally pass in what they want, and we need to know how to handle that. So we'll handle our sunny, rainy, and cloudy because that's what we told the user about. And here for cloudy, we can say you might still go out, just bring a light jacket. If it's cloudy, that means there's no sun. Maybe it's a little chilly. We can go ahead and refactor a little bit of this code. Let's change our sunny print statement to something like, great, how about going for a walk? For a rainy one, maybe stay in and read a book or watch a good movie. This can stay. That seems pretty fitting. And then for the else statement, let's go ahead and change it to something else that's a little bit more explaining for the user. We can say something like, not sure about that weather, but find something fun to do anyway. There we go. And now we can handle in the event they add some kind of weather that we're not tracking. Let's give this a quick run. We can say cloudy. We see here we get the cloudy statement down here, and now let's add something like drizzling. And we see here, not sure about that weather, but find something to do anyway. Awesome. So now we are handling all three of our values of sunny, rainy, and cloudy. And also we have the else statement to check if they give us something that doesn't fit. Now this is always important because you want to check for all possible situations. A user could possibly pass into you value that isn't to the format that you're checking for, or they might pass into you values that you're not taking into account. Then it can lead to some errors or some awkward functionality. Software engineers write code like this all the time. For instance, in an e-commerce app, the system might check if a user's cart total is above a certain amount to unlock free shipping. Now, for some key tips and best practices, make each condition straightforward to understand. If they get too long or complicated, consider breaking them down into smaller parts. Reset. Tips and best practices. Make each condition straightforward to understand. If they get too long or complicated, consider breaking them down into smaller parts. Users might type something unexpected. Plan for that by handling all possible cases. Our example used an else clause for anything that was not sunny, rainy, or cloudy, and we also took into account in the event that they added something that wasn't that to the standard that we were checking for. Conclusion. Great job. You built a simple, interactive program that makes decisions based on user input. This is exactly how software engineers handle day-to-day tasks, writing code that responds to various conditions. Take this concept and run with it. Try building a program that suggests a meal based on the time of day or checks if a password is secure enough. The more practice you get, the more confident you'll become. In the next lesson, we'll move on to loops, another key way to control the flow of your programs. Stay curious, keep coding, and I'll see you there.